All right, so this section is going to cover some basic geometry. So it's really just a quick review of some of the fundamentals. We'll do a few extra examples involving circles because in your trade, you use circular geometry more than you use any of the other. So by the end of this lesson, we should be able to solve for perimeter and circumference of simple and compound shapes, and we should be able to solve for the area of simple and compound shapes. We're going to follow this up with a very short lesson on volume once this one's completed. All right, so my formulas are somewhat covered, but I think we're close enough here. So starting out, we're going to look at just a couple of definitions. I know this is probably familiar to most of you, but just to make sure we're all on the same page. So perimeter is the distance around the outside edge. So if I take my pen and I follow the outside edge of this rectangle, that's our definition of perimeter. So perimeter is around the exterior edge of a shape. It could be traced with a single line, okay? Units for perimeter are always going to be linear units. So it'll be centimeters, meters, millimeters, inch. They're always a one-dimensional unit. Now you look at area. Area is just the 2D space in between. Let me change my pen color here. So area is when we fill in the space. Okay, so it has both length and width. We can't use just a single line to cover it. It's the area that would fill inside of the perimeter. Now, I've said already it's a 2D measurement, and it's always expressed in square units. So you'll see there's square centimeters, square meters. We put this squared on the end. You want help to remember it. A 2D object, so a 2D area, the units will always have a 2 involved. Okay, they always have a square on them. One of those little easy mind tricks to help you remember that if you see something that says a squared unit, it's going to be an area. Now, because it has length and width, when we take meters times meters, because that's what happens when we do a rectangle, we take the length and we multiply it by the width. When we do that, meters times meters always is going to give us meters squared. So that kind of gives us just our quick key definitions and a few things to look for. So we're going to jump into just doing some example problems in order to refresh in our minds perimeter, area, and volume. This question says, how many square feet of shop floor space does a rectangular pallet take that is 90 inches by 48 inches wide? So the first thing I do in a question like this is I'll sketch it. So this is the rectangular palette. I'll often throw that in. We're 60 inches in that direction, 48 inches here. Now that we have that, let's look for our formula. So how many square feet? It doesn't say area, but when we see square feet, we know we need to calculate area. So the formula we're going to need to use is for the area of a rectangle. So area equals length times width. Let's pull out our information. So we have a length of 60 inches and a width of 48. So let's plug that information in. So 60 inches by 48 inches. Multiplying that out, I've got pre-multiplied on my answer sheets. Multiplying that out, we get 2,400 or 2,400 inches squared. So we did inches times inches, so we have inches squared. Now, if we look back in the question, it says how many square feet? Well, we have square inches and we need square feet. I'm going to give you 2 ways to do this. So if you don't remember this right off the top, we're going to do this a couple times, but I'm going to give you 2 ways to convert. So we need to go from inches, and so well, that's going to be equal to how many feet squared. Now, normally, if you were going from inches to feet, you divide by 12, because we know, let's put the conversion up here. 1 foot is equal to 12 inches. But you'll notice there's not a square on this foot and there's not a square on these inches. So what we're going to do is let's square it. We're going to find out 1 foot squared I'm going to square the inch side. Whatever you do to one side, you do to the other. It keeps it balanced. It's going to keep it equal. So we have 1 squared is 1. So 1 square foot is equal to 12 squared is 144. So we're going to take our inches. And, well, I'm going from inches to feet. So this is going to be division because I'm going from the larger number down to a 1. So I would have to divide 144 by 144 to get to 1. So we're going to divide by 144. And when we do that, whoops, we find we get 20 square feet. So I'm going to call this method 1. Okay? Method 2. So that's one way to do that question. With these questions, there's often more than one way to do them, especially when there's unit conversions. Now, the second way to do this is when you're reading the question, if you take note that, oh, it needs to be in feet for my final answer. Let's change all of the measurements to feet at the beginning. So our length is equal to 60 inches. 60 inches, that's not square inches, just inches, so we can divide it by 12 to get 5 feet. Width is 48 inches. Divide that by 12, gives me 4 feet. So our area is equal to 5 feet times 4 feet. Gives me 20 square feet. And that's another way you'll see square feet written is SQFT. Okay, so, or we could do feet squared, writing it out more like a math problem. Okay, so those are the 2 ways to do it. So we can convert measurements before, or we can convert after. If we're converting before, we have to watch this squared unit. And to do the squareds, we're going to have to come up and we're going to have to square our conversion. You're going to see several of those come up, but if you're in doubt, change your measurements at the beginning. Sometimes it will be easier to do it at the end though, so it's good to know both ways, and I think it's not difficult to practice both methods. For this next one, we want to determine the perimeter and the area of the following shapes. So this is just a schematic for an angle iron. I want to know the perimeter around the outside and the area that's shaded. So we have several measurements that are given to us. We know the height is 1 foot. B, the base, is 8 inches. And we have a 2-inch thickness. I said angle iron. Pretty heavy stuff if that's the case. So for height, the first thing, let's read through the question. We'll check our units. Determine the perimeter and the area of the shape in square inches. Okay, given the following measurements. So now let's look here. We have mixed units. So make them all 1 unit. Rather than using mixed units. So I'm going to say, well, the height 1 foot is 12 inches. B is 8 inches. Why am I going to inches? I'm going to inches because the answer is supposed to be in inches. And this is 2 inches, and we have 2 inches over here. All right, now let's find out our perimeter. So if we need to know the perimeter, we're going to follow around the whole outside of this shape. So 12 inches here, 2 inches there, we know that side. We need to figure out what's the length of this shorter side here. Well, this short side is 12 minus 2, we get 10 inches. And then along the bottom here, 8 inches all the way to the edge, take 2 inches off here. This one is 6 inches. Okay, so plugging that all in, so we're going to have 12 plus 2 plus 10 plus 6 plus 2 plus 8. Now there is a shortcut. I'm not going to tell you what the shortcut is. If you happen to see it for L-shaped objects, there's a shortcut for perimeter. If you know what it is, or you think you know what it is, feel free to pop me a message and I'll let you know if you're right. Adding all of those together, we get 40 inches in total. So we added inches, we're going to get inches out. And that's one of the reasons why we want to have all of our units the same. Now to find the area of this shape. It's not a simple rectangle, but it is. So what we are going to do is we're going to break the shape into two. It doesn't matter which way you cut it. I'm going to cut it across here. Okay, breaking it into two shapes. Now we have two rectangles. So we're taking a complicated shape and we're making it into simpler shapes. For this rectangle, it has I'll call this A1, and we'll call this one A2, and we'll figure out our measurements. So the area is going to be equal to area 1 plus area 2. So area 1. Area 1 has a length of 10 and a width of 2. So 10 by 2 gives me 20. Oops, I can't write it that way. I always want to add the inch symbol, but the inch symbol does not work with squares. I put it this way, it looks awfully strange if you try to use it. So 20 inches squared. Area 2 is equal to, well, that's down here, 8 inches times 2 inches. Gives me 16 inches squared. To find the total, we're going to add them together. So our total, adding the two shapes, the area is equal to 36 inches squared. All right, so nice and simple, just breaking two shapes into one. That's about as complicated as I can get doing a rectangle question for you. Okay, so we've done a rectangle that's got a perimeter. I'll admit, this formula, P equals 2 length plus width, I rarely use that formula. We'll use it a couple times when we get to doing some algebra questions, but I find if you can sketch something out, it tends to be easiest. Now, for this particular question, the reason why we didn't use the formula for the perimeter of the rectangle is because this side here is shared. So you wouldn't want to include that in the perimeter. It's not the outside. But if we have just a simple rectangle, let's say it's 3 feet by 4 feet, the perimeter is equal to, well, we have 4 feet here and 4 feet here. So that's where the two, well, I guess the length and the width are the same. These two sides are the same there as they are over here. So we get 3 plus 4 equals 2 times 7 equals 14 feet. Okay, so that would be how you use that formula if you needed to use it. So you can only use the perimeter formula for a simple rectangle. I find more often than not we end up dealing with a slightly complicated problem. All right, jumping on to our next question. We're going to look at a couple triangle questions. I'm just refreshing again some of the principles of the formulas for triangles. So for triangles, perimeter is just going to be the sum of the sides. We add all three sides together, where area is going to be base times height divided by 2, or 1/2 times base times height is another way to write that. So we want to determine the perimeter in meters and the area of the following triangles in meters. So in order to do that, let's figure out our perimeter first. The perimeter is easy. If we want to find it in meters, let's move our decimal place. Okay. We move our decimal now. We don't have to worry about it later. So we move our decimal 2 places to go from centimeters to meters. So the perimeter is going to be 0.222 plus 0.243 plus 0.298. Those are all in meters. Okay. Actually, I'll write that in just in case somebody's wondering, what am I doing? So 0.243 meters, and this one is 0.298 meters. Okay, so that gives you all your measurements. All right, so adding all of those up, if you take a sum, you will get 0.763 meters. So I'm throwing in some conversions here just to keep you practiced on them, so you're looking for them because you will see them in some of your quizzes, and you can expect to see a couple conversions on a midterm. You won't have conversions for all of them. Now we want to figure out area. So what is area? Well, first of all, we need to figure out what's B and what's h? So the base, I find it easiest just to take the bottom edge. You could take any side you want, but the height has to be at a right angle or 90 degrees to the base. So that's been given to us here. So that means this one must be the base and this must be my height. So our base is 0.298 meters and the height is 0.178 meters. Notice I've changed it into meters at the beginning. I'm going to convert from meters to centimeters. It's so easy. It doesn't really take much math. It's just moving a decimal place. That often those ones are easier to convert at the beginning. You could convert it later. If you convert it at the end, don't count your decimal places. Think about dividing by 100 squared, okay? So if I find for meters or centimeters, those kinds of things, change your units right at the beginning because it is just a decimal place. So our area is going to be base times height, so 0.298 meters times 0.178 meters, all divided by 2, which gives us a measurement of 0.027 meters squared. Now you'll notice I haven't told you in these questions where to round to, and I'm just using logic in order to figure them out. I'm keeping 2 to 3 digits in my question because there's 3 digits here. So I'm just using approximations. And your quizzes on SAM are very specific for rounding, so you won't have any trouble there. And when we get to the next one, we have another triangle. This triangle has a little bit different shape for us. You'll notice we can't, our right angle would only, if we did it inside, right from the base, it would only go to this edge. So we want to go to the highest point. So we extrapolate out, and to get to our highest point, we go up there. So it's the highest point from the base, if the base went out this far, up to the peak or up to the top of the triangle. Now our base is still going to just be the portion of the triangle that's marked. We do not include this section. One of my answer keys, one of my solution charts makes it look that way, and it's a little glitch in the formula sheet that I'm going to have to do a little creative editing on. All right, so if we want to know our perimeter, we're adding all 3 sides, so 6 plus 8 plus 10. We don't have to convert anything in here. 6 and 8 and 10. Whoops. Let me see. I missed a side. I did a mistake that maybe I should just point out. I added this 8 just quickly when I'm writing things down here. But for perimeter, I want to include 10, 6, and 8.5. So I need to include that longer side. So we'll just go back and add that in. That's a really easy error to do, and it's funny because I picked this question intentionally because of that, and that just goes to show without enough coffee, even I can make that error. So putting all of those pieces together, we get 24.5 meters as our perimeter. Now we want to figure out the area. So our area, again, it's base times height divided by 2. So that's going to be, we got a base of 6 times a height of 8 divided by 2 gives us, and our 6 and 8 were in meters, so we're going to have 24 meters squared. Now I need to pause here just for a second while I plug in my computer because it seems to be lagging. All right, now that we have that, we'll jump into the next one. So the next shape we're going to look at is a trapezoid. I'll often use a trapezoid as an example of a blade wing. We used to do exercise where I'd have you go into the shop and calculate the area of a bunch of things. And if you look at the blade of a turbine, because the edges aren't perfectly square on them, you can approximate it pretty well using the shape of a trapezoid. If you're not sure, take a look at it. See, there might even be some green tape left on it from when I sectioned them off for doing my calculations with you. So trapezoids can have a couple of different shapes. A trapezoid could look like this. This would be a trapezoid. So trapezoids are characterized by 2 parallel lines, and then the other 2 edges, we don't necessarily know what they are. They're quadrilaterals, meaning they have 4 sides. It could be like this as well. So similar to what's on the bottom there, but where these two angles are equal. So that's another trapezoid that we could have. If these two angles are equal, it'll mean these two sides are exactly the same as well. All right. So we are going to do a calculation here. So perimeter, it's nice and easy. We want it in square inches. Because there's a lot of things to calculate here, I'm actually going to keep it in centimeters and I'm going to convert it at the end. It's going to be, I think, easier for us to do that. So we have 10 plus 7 plus 20 plus 7 gives us a total perimeter of 44 centimeters. Now we need to convert that. So 44 centimeters times, I'll write it out using the fraction method just to jog your memory. So 1 inch is 2.54 centimeters. So 44 divided by 2.54 leaves us with 17.3 inches. So nice and easy. Now we want to calculate the area. The formula for area is big B plus little b divided by 2 times the height. So what the bases are is we're taking the average of the two longest sides, or the two parallel sides. The bases are always parallel to each other. So we're going to take the average of these two. So I'm going to call this one big B. It's a long side. We'll call this one little b. Again, I'm going to leave everything in centimeters and I'm going to convert it at the end. It'll mean for one calculation, you will get exactly the same answer if you converted early. The decimal place could be off just a touch. All right, so sorry about that. I had an interruption with an urgent email I had to respond to mid-video. So for calculating the area, we're going to use the formula that we have over here. And I'm going to go back to full screen. See if I can get full screen to work. There we go. So we're going to use the formula that we have over here. So our base 1, or our big B, is going to be 20 centimeters. Our little b is 10 centimeters divided by 2 times, and you'll notice here there's a note, height must be measured 90 degrees to the base. So for our height, we're going to use 8 centimeters. So those are area pieces. So this is going to give us 15, so 20 plus 10 gives me 30 divided by 2, 15 centimeters by 8 centimeters. Brings us to a total of 120 centimeters squared. All right, now again, we want square inches. So in order to go to square inches, well, let's use our fraction. So normally what we'd say 12 inches for one, whoops, I'm not sure what I'm doing here. Not enough coffee yet. We'll fix that. So 1 inch is 2.54 centimeters, but because this was squared, we're going to square the top. 1 squared is still 1, and then we have to square the bottom. So it's going to be 120 divided by 2.54 squared. Okay, so I'm going to write that in here. So 120 divided by 2.54 squared leaves us with a total of 18.6 square inches. Okay, so they're just converting the units at the end is sometimes a little bit new for people, but it shouldn't be too bad for you. Give it a try a couple of times, see how you make it. Determine the area in square centimeters. We're going to do another one. So again, we have our big B, our little b, and for height, this one is not at 90 degrees. We're going to use the 5. So this is my height. So plugging it into our formula, and I'm going to do this using the converting at the end because I think it'll be good for you to see it again. So 9 plus 7 divided by 2 times 5 leaves us with 8 times 5, which gives me 40 inches squared. Now I want square centimeters, so 40 inches squared, use our fraction method, so 1 inch is going to go on the bottom, and then 2.54 centimeters goes in the top. It's squared here, so again, we're going to do a squared conversion, so that makes everything in here squared. So 40 times 2.54 squared leaves us with 258 centimeters squared. All right. Now, when I put this in my calculator, the way I will type in my calculator, I write 40 times 2, 14 instead of 40. 40 times 2.54 squared equals. Okay, so that's what it looks like in my calculator, so you don't see that fraction part. Sometimes that can simplify things a little bit for you. Now the last piece we have to look at, I want to take a minute and look at circles. So for circles, there's some circle-specific language that we need to review. So first of all, let's define what a radius is. A radius is from the middle of the circle to the outside edge, okay? Diameter goes edge to edge through the center. And then circumference is around the outside of the circle. Circumference is the same as perimeter. So if you have something circular and you're looking for a perimeter, for the first part of a circle and something, and you're looking for a perimeter, you're looking for the circumference. And the other thing that we need to know is we need to know what pi is. So pi is this fancy Greek symbol. It's like 2 little lines with a squiggle on top, works for drawing it. We call that pi. It represents a constant that's 3.1416. I used to know further, but my brain is fried at the moment. It's a constant that it repeats for forever. So we usually shorten it. Sometimes we'll say 3.14 is pi. For Sam, the purposes of using Sam for doing quizzes, we're going to say pi is 3.1416. It's going to make our answers just slightly more accurate because Sam's a little goofy rounding sometimes. But what it is, it's a ratio of the diameter to the circumference. That's where pi came from. Some lovely Greek mathematician did lots of research with circles, comparing diameters and circumferences, and came up with a relationship pi to connect to show the relationship between the two pieces. So our formulas for a circle, and I've got P for perimeter, we could say circumference, so C we'll often use, is going to be 2 times pi times the radius, or since 2 radiuses make a diameter, we could also say pi times diameter. So you can use either formula, whichever one you like. Area is going to be pi times the radius squared. So area will only use radius, and it can only use radius. You'll never use diameter for area. But perimeter, you could use either radius or diameter. Both of them will work as long as you choose the correct formula. Mind you, I can ask you area of a circle and give you a diameter because you can take the diameter to find the radius, okay? So just because a question gives you the diameter doesn't mean that it's not going to be an area question. So we're going to do just a couple of easy questions. So we're going to determine the circumference of a wire spool that has a core diameter of 1 foot 6 inches in feet. So the first thing I notice when we want to find the circumference, diameter is 1 foot 6 inch, and I want feet at the end. So let's take our diameter and convert it to feet. So diameter is going to be equal to 1 foot 6 inches. So 6 over 12.5. So we have 1.5 feet. I should not have to do math for that. I just did it simply for the sake of demonstration. Do not write 1.6 feet. That's not allowed. 1 foot 6 inches is 1.5 feet. So now we want to go and use our formula. So circumference is like calculating a perimeter, so we can use this formula here, pi times diameter. So circumference is pi times diameter, which is going to be 3.1416 times 1.5, which gives us a diameter of 4.71 feet. And I'm keeping some extra decimals in there just because I haven't told you where to round to. If you went to 4.7, I couldn't argue with that. I'd be hesitant to go to 5 though, because that's quite a little bit of rounding involved there. Especially when 1.1 foot 6 inches tells us we should be able to get accurate to kind of inches, get close to inches. So probably 1 or 2 decimals is going to make sense for us. So that's as easy as that one is. Then I want to know how many feet of wire are in 10 wraps. So if we've wrapped around this spool 10 times, then I would say this layer here looks like maybe it's about 10 wraps. How many feet of wire would there be if I pulled that much off? Well, 4.71 feet times 10 wraps gives me 47.1 feet of wire. All right. Now what happens is every row of wire comes off while the length of wire underneath gets smaller because our diameter keeps getting smaller, or our radius keeps getting smaller. So this is one where it would be some substantial math if we want to calculate exactly how much wire, but it does work for just figuring out about how much is on a single, approximating how much is on a single wrap. And if you were in the shop doing a measurement activity, a station I always have is a wire spool, and I get you to determine approximately how many feet of wire are on whatever's remaining in the outside wrap of the roll. Another question, now you guys won't deal with fiberglass until next semester, I don't think. That's one of the last units you guys usually do. So, but this is a good type of question. A circular area with a diameter of 425 millimeters needs a fiberglass patch. I know you sometimes have to do repairs on things, so this is just a good example of area. You need to know how much fiberglass are you going to need. How much material do you need to do the patch? What is the area of the area? This is a bit of a tongue twister, which needs a repair in square inches. So what's the area of the section that needs the repair? So we've got a circular area, and it's probably an approximate circle. Diameter, but you know, so our diameter is equal to 425 millimeters, and we want to know what's the area in inches. Okay, so in this question, because there's only one measurement, it would be easiest just to convert it right at the beginning. So our diameter is 425 millimeters. If we take that and we divide it by 25.4, there's 25.4 millimeters in an inch, we find that it's equal to 17.35 inches. Now, in order for us to use the area formula, we need to know what's the radius, okay? So see, our area formula uses radius. So radius is just half of our diameter. So we're going to take 17.35 and we're going to divide it by 2. And when we do that, now I left some extra decimals when I was doing my calculations, and I didn't delete anything off my calculator. So I'm going to recalculate this one just so we end up with the same measurement. It could be out by a decimal place on this if you keep all the decimals in the calculator. And I'm getting a syntax error. It's always a good way to start the day. So we have 8.68. I'm going to round to that. 8 inches is our radius. So plugging it into our formula, area is equal to pi times the radius, 8.68 inches squared. This is where our squared inches comes from because we square our radius. So pi times whatever 8.68, 75.34 Multiply that by pi. Gives us 236.7 inches squared. So that's the area. That will be the area that we need to repair. Seems like a very large area, but that is what the numbers line up to. 236 square inches, I guess that's one square foot is 144, so that's not that big. I just have to think in other terms in order to visualize what does that size of piece look like. So it's almost 2 square feet. That's not too bad. All right. So that has us with a quick circle question, and we're going to do one last question. This might have been a little bit longer than I intended. One last question. I want to find the area, the shaded area shown in square millimeters and square inches. So this schematic I have just pulled from somewhere, thanks to Google, and all of the dimensions are listed in millimeters, and we want to know the area that's shaded. So in this kind of question, think about what our shapes are. So we have a rectangle that has a triangle cut out. So there's our triangle. And then we subtracted a semicircle from that. Okay. So that will give us the approximate shape here. So we have a rectangle minus a triangle minus a semicircle. So let's calculate the areas of each of them. So the area of the rectangle, I like to kind of draw pictures because I find it helps keep things straight. So this piece, all the way across the top, we have 800, 400 plus 200 plus 200, 800 millimeters times a height of 700 millimeters. This gives us 560,000 millimeters squared. This is one of the reasons why we might not like millimeters very much. Okay, so we have the area of that. Now we want to figure out what's the area of the triangle, or area, I labeled it as area 1. So area of the triangle, so we need our base. So these are at a right angle to each other. So my base I'll use 200 and 400, or you could use 400 and 200. So base 200 times 400, all divided by 2, leaves me with 40,000 millimeters squared. Okay, and the last one is the area of the semicircle. So the semicircle, we're already given our radius. So the area is equal to pi times 300 squared, which leaves us with 382,743 millimeters squared. All right, so now that we have all of those, we can just do our math subtracting. So we're going to take our square, we're going to cut off the triangle, so that'll get rid of this piece, and cut out the semicircle. So the area total is equal to 560,000 minus 40,000 minus 382, which leaves us with 137,257 millimeters squared. So that leaves us with all of our pieces in inches. Well, we need to divide by 2.25.4 to get from millimeters to inches, but because we're in area, we're going to divide by 25.4 squared, which would give us 212.7 inches squared. So I kept a couple extra decimals in there. So there's our two answers. So simple enough calculation, just a bunch of little bits. So final summary reminders. You don't need my video here anymore. You probably didn't need it the whole time anyway. Summary reminders, before you calculate, make sure you're using a single unit. So if you have mixed like feet and inches, put everything in feet or everything in inches. If conversions are made at the end, make sure you square the conversion factor. And if it looks complicated, break it down to simple shapes. Okay, keep it simple. And that will usually help things out.